Hi and welcome to everybody. This is Ritu from Xoriant, and I welcome everybody who's on this webinar and here to attend this essential strategies for containerization. Now I invite Sunil, our first speaker for the session. Sunil, over to you.
Hello and welcome to this short session on the topic of containerization. My name is Sunil Bidwalkar and I belong to Xoriant's technology practices. Of my several roles, one is to work with our clients to design and define strategic solution architecture to solve their business and technology problems. I've been actively following technologies which improve the overall efficiencies of software development and implementation life cycles, such as Kubernetes and Docker. And I'm very pleased to be here and speak to an august audience from various parts of the globe representing diverse business domains. Today, I'll be joined by Paul Abraham from SAP and Atul Dambalkar from Xoriant. As you can all see, each of us has very long association, almost 20 years plus, with our respective companies. Paul has a very deep background and is very passionate about his subject. He was in academia before and he currently leads data science for a product of SAP called SAP BI. We are very happy that he has taken time out from his busy schedule to share some of his insights, which we'll hear towards the later part of this session. Atul, as you can see, is one of the very few people who were fortunate enough to work with James Gosling pretty much side by side during early years of Java. I'll start with some general principles, high-level observations, and what we are seeing with respect to our customers around the key topics of containerization, such as Kubernetes and Docker. After that, Paul will speak in depth on his current area, which is a technically complex and a business impacting case study, how SAP migrated one of their product lines to containerized environment. We are absolutely open to taking questions and have kept aside a few minutes towards the end. Please feel free to send in your questions over the chat window and our anchors will pass them to us. Should we run out of time, we'll definitely respond back to your questions over email. The session will be very interactive and please be on the lookout for 3 polls along the way. I request you to please participate and indicate your answers on the screen as and when the poll comes up. So let's get started with our first poll so that we can get to know you a little better. On the screen, what you're seeing is a very short question. I request you to please choose one of the options. The poll will stay on the screen for a few seconds, after which we will know what each of you are thinking about. All right. So do we have the answers? Extremely interesting. This is no different from what we see when we talk to our customers, and it does show that close to half of you have started thinking about it, are looking at technologies, are evaluating options. At the other end, there are a good part of people who have covered pretty much a good journey and are convinced about this technology and are also sharing it with others. So let's get started. This gives us a very good idea about the kind of group that we are here, and I'm looking forward to more questions towards the end. Now to start with, what is a container? I don't want to give a technical definition. The container, in my opinion or our experience, is the smallest unit of an independently executable environment, typically designed to run a part of an application. Of course, with an intent that in the event of higher performance needs, that part of the application can be scaled up. Of course, if you put the entire application in a single container, it begins to feel like a virtual machine. And therefore, it is very common for people to confuse a container with virtual machine. But clearly it is not. A container is composed of several layers on top of each other. For example, there's a very minimal OS layer, a very minimal set of libraries, a very minimal application binary, whereas the virtual machine is an entire operating system running on its own hardware enforced boundaries. And why do our clients embrace containerization? As you can see on the right-hand side, here are some of the reasons we are seeing on the field. For development teams, there are very clear process efficiency opportunities to smoothen the development pipeline and really minimize the time between the developer commitment and the code availability in downstream environments like UAT and production. For some of our clients, scalability is an important factor, especially if they cater to retail customers and there are seasonal peaks in volume. Likewise, directors and VPs of engineering teams, they aim to enhance the engineering productivity by allowing developers to focus on core development activities, letting the system take care of the deployment. Now, how have we reached where we are today? Go back to maybe 25, 30 years, 80s to 90s was pretty much about dedicated resources. If you wanted to build and deploy an application, you go and get your own server or a set of servers, manage the capacity and run it. Once virtual machines came in, people realized that it is possible to share resources optimally. So we saw a huge shift, or almost a de facto pattern, to procure a really large set of hardware and provision it into virtual machines. But of late, especially in the last few years, we are beginning to see the benefits of both, whereby the virtual machines have a role and so do the containers. And the combination of that is becoming the accepted norm. And as I see from the audience mix, you all have already tried out and experimented and got your own perspective on where we are. Now, when it comes to this technology, you normally hear a lot of buzzwords which are being used interchangeably or in the same breath. As you can see here, essentially they have different roles. Docker, in this moniker, is the audible piece of music that you see a performer come to the stage and play. But Kubernetes is the behind-the-scenes orchestra leader. Even in the video that you will observe shortly down the line, you would see the engineer executing a lot of Docker commands to create and define the containers. However, Kubernetes comes into picture when the application or some of its parts have to be scaled up. For well-designed applications, especially from containerization point of view, and especially where separation of duties is well defined, Kubernetes handles the launch of additional instances depending on certain system parameters like CPU load, etc. And as the overall load decreases, Kubernetes also shuts down spare instances, making sure that in-flight transactions are properly drained out. The same thing has been depicted on the diagram on the left. Docker-associated planning and Docker commands are very active in the initial parts of the project, whereas Kubernetes has a continuous and ongoing role at all stages of time. So, how do you go from where you are to where you want to go? What you see essentially here is a 5-step approach commonly followed by our clients during the journey. On one end of the spectrum, we have clients who are just getting started. As I see in the survey, 46% of you are there. The first step is identifying the application to be containerized. We typically look at aspects like need for scalability, business impact, cost to go-to-market, etc. Either concurrently or as an immediate step, there may be a need to do some prima facie technical assessment of these applications. There could be cases where application architecture or technology stack are better suited or require significant rework. We have seen clients spend good amount of effort in the first 2 steps as it sets the stage for further work. Another important factor is to make the call on the role of cloud, especially public cloud. So we have seen clients who either do development on cloud and production on-premise, or they both on cloud, or some customers do production in-premise, disaster recovery on the cloud. However, good part is in most of the cases, since the public clouds also support the common tools like Kubernetes or Docker, the final choice is not just a pure technology choice anymore. And in each of these areas, Atul has published a whole set of blogs on our website, www.xoriant.com/blog. Since he's on the call also, please feel free to ask any questions about this slide or the other blogs to Atul. Now, before I hand over to my co-panelist, may I please request your attention once again back for a short poll. Your answers, just as the previous poll set the stage for my conversation, will set the stage for Paul to talk to you about what he has to share. So, once again, this poll is a little different format. It's not that we choose only one of them. I urge you to choose as many as you really feel comfortable. You can pick one or two or three. I'm sure aggregate, the picture may look very different, and Paul will have a final comment on it from his perspective. So may I please request your 2 seconds of attention here. All right, so looks like we to have what most of you are, oh, that's very interesting. Faster delivery clearly scores out as a very, very high. Portability and flexibility really, really high, above 80. But happy to see that everything is above 50%, which means that we probably have identified the 5 most important areas here. So now I'll request Paul to please continue this conversation. Thank you, Paul.
Thank you, Sunil, for the introduction. By way of introduction about our company, SAP is the market leader in enterprise application software, helping companies of all sizes and in all industries to run at their best. We are known for our extensive range of applications that have automated more than 2,000 business processes. In fact, 77% of the world's transactions, revenue transactions, touches an SAP system. We have been in business for about 40 plus years and right through the evolution that Sunil alluded to previously. SAP has embarked on a multi-billion-dollar transformation to a cloud services company. The SAP Digital Interconnect business unit that I work for is a division in the cloud business and provides API-driven engagement and interconnect services that connect businesses, people, and things in this digital economy. It helps enterprises connect the last mile between their enterprise apps, SAP, and other applications to their customers, employees, and things from an IoT sense. We offer products such as SAP SMS 365, SAP IoT Connect 365, SAP People Connect 365, SAP Authentication, SAP Live Link, SAP Social Channels, SAP Email, SAP Contact Center. So yeah, we have a bunch of products. In terms of the number of transactions within SAP Digital Interconnect, we process about 1 billion messages a day, which are carried over these SMS routes, connecting the enterprise to individuals through telephone operators who are our vendors. We actively manage about 500 operators and about 70,000 routes, among them servicing our ever-growing list of customers. Every day we have about 40-50 route changes that are updated for cost, features, and other changes, and routes are added on and old routes are sunsetted with high frequency. So we got to manage all this. The current application that we are talking about, ADS, helps our sales force to create offers and for these SMS routes to meet the customer requirements, and also helps our operations personnel configure those routes to work for customers in specific accounts. And so it consists of a classification engine that's able to mine customers and carriers messages and classify them into categories. A flowcasting engine, which is a forecasting of the message flow by volume or by category, carrier routes, etc. A pricing advisor that helps prepare custom quotes based on flow casts and constraints imposed on objectives, which are defined by the salespeople. And we have something called margin nowcasting, which is essentially a reporting engine that reports your margin or your margin position right up to the minute. This is because the SMS business is a very, very competitive business with very fractional, profit per message. It's really in like fractions of a cent, the profit. And then finally, we have a route matching engine. And this is based on some kind of routing. It's OR, operations research algorithm, essentially. So some fun facts about SAP. We have 437,000 customers in more than 180 countries, 99,700 employees in about 140 countries, and about 18,000 partner companies globally. We are at $25 billion revenue with over 200 million subscribers in our cloud user base and over 100 innovation centers, which are peppered across the world. I'm based in Chicago, but there are development centers all over the world. In this slide, I'm going to give you a high-level view of how our landscape is and how we work. Currently, we have 2 Docker containers running on 2 virtual servers that can be replicated and spooled up and down depending on the demand for these services. Now, due to the history of the division's growth through acquisitions, we have several systems of record, and we have never consolidated those systems into a single monolithic system. But due to the complexity of merging several lines of business and the sheer volume of data. So the data for the ADS system is bought from these systems of record on an as-is basis and stored in a cache in the middleware components. The data is consumed mainly by our sales staff and operations staff outside of the firewall, either from sales offices or operations offices, or in the case of sales, while on the road. Hence, we have what is called a responsive front-end design that adapts to the form factor of the device. As you can see, we have all the complexity and headaches that modern IT teams have to contend with. One, a widely dispersed mobile workforce working on varied devices outside of the firewall. So tablets, phablets, phones, and of course, laptops and computers. Demand that scales up and down depending on the time of the day, depending time of the week, depending on the time in the particular quarter, and even in certain geographical areas also. So things like move along with the sun. Data that is dispersed across many, many data centers across the planet. So this is what we have to contend with. So we came up with this technology stack to address the situation. So we use JavaScript running on Node.js servers to implement our responsive design. We mainly use React.js, which provides us the MVC framework, which we need for rich interaction. In addition, we have high performance UI widgets like grids, graphs, calendars, and other controls that we reuse from SAP Fiori, React, Angular, all of those. The thrust of my presentation will be all the components we developed using this technology stack and how we package them for deployment in our data centers. So currently our application is cloud ready, but still running in our data center. And we are hoping sometime in the near future, we will be migrating to one of the major cloud, services providers like Amazon, infrastructure services providers like Amazon or Azure or Google Cloud. So I'll give you some insight on the decisions we made and why we made them in the manner we did. One thing is that Node.js and xQuery allows us to implement REST-based UI microservices very easily. The Tomcat server and Spring Boot provide the same ease of development in the middleware. We use an in-memory database, MS-SQL, to implement a cache, and we use MongoDB, which is also in memory, to provide a completely personalizable UI screen for our users. What that means is the user, depending on his form factor, can decide like what pieces of information that he sees in, say, in a grid or a spreadsheet or whatever it is. And those things, it remembers it for every single screen, for every single device that the user has. The intercomponent and inter-server communication is effected through a Kafka messaging server, which is also built right into the containerized components. The web container is implemented using REST-based services, and also we use this for security, in the backend. Okay, we'll go into that a little more in detail. So first, I'm going to show you a little video on one of the upgrades that occurs for this application. Okay. In general, it takes about 14 to 15 minutes, but here we have a condensed version just for you to see how quick and easy this is. So that's it. Now the application is up and running, and you can see it was a fairly painless process. Now I'm going to talk to you about the architecture. ADS follows a layered architecture. As mentioned, the presentation layer consists of a Node.js server from which we serve up the JavaScript web pages for sales and operations module. That's what we have implemented thus far with Xoriant's help. In future, we expect to deliver modules for the margin committee and for the execs and for some other lines of departments. In the middleware, we have a Java integration layer wherein all the business logic pertaining to all the process flows in ADS reside. In addition to this function, it serves to integrate with other services like our security service and other data feeds and data services and application services. In here are the finer grained components shown above, and we will discuss these fine grained components also in a later slide. Finally, there's a data platform consisting of several data repositories, of which the biggest one is we call Data Mart, is our single source of truth for all business data, which resides in special protected domain in the US within our company due to Sarbanes-Oxley requirements and in another failover location. In addition, we have several operational systems that contain our quality and performance data that reside in US, UK, and France operational data centers. So for now, we have two Docker components, which consist of several subcomponents each. This is because due to the current size of the organization and the demand on the system, we decided we do not need at this moment more fine-grained components, but we'll discuss this a little more later. And we also decided not to Dockerize our data platform, since this will continue to live as a monolithic piece within our data centers, exposing its data through interfaces such as REST APIs or JDBC for relational data or live stream feeds in many different formats like RSS and JSON, etc. So we, put a long wire to this and make them composable Dockerized components that we can attach to our application. Authorizations is through a single sign-on system, and we will discuss this. In this slide, I'm going to talk about the external services which we have encapsulated as microservices. So firstly, we have Keycloak. We have implemented a role-based access management using Keycloak and LDAP. LDAP is the authentication store and Keycloak is the authorization store. Authorizations are hierarchical and follow our org structure. We have a Keycloak node library at the UI layer and a Spring library at the backend service layer. The user information is automatically configured into Keycloak from LDAP. So when the user logs in, basically a token is returned from the Keycloak server with the roles and the attributes configured in that token. The token is then passed along with every service request. The service on receipt sends this token to Keycloak for validation and authentication. And the roles and attributes in the token are used for the UI authorization. Okay, so you can see that it is very, very chatty. Second thing that we Dockerized was Kafka, our messaging bus. We have implemented a Dockerized Kafka server on both the UI and the service layer. It is basically used for in-app notification and inter-service communications. The in-app communications can be UI to UI, service to UI, user to app, app to app, app to user, all combinations. And also we have background jobs that fetch data from different data sources and publish it on a topic and subscribed by the UI, currency rates and other, forecasting information like subscriber information, quality data that is reported by the various vendors, systems, etc., which are outside our firewall and they have to come in. So in general, the middleware services only produce messages while the UI does both production and consumption of notifications. In this slide, I'm going to talk about the UI microservices. So ADS has two separate UI containers for sales and operations. That's what we have implemented thus far. And they can be independently deployed and managed. The Apache proxy server helps redirect the UI request to specific UI services based on the configured URLs. These are further authenticated using Keycloak. So each UI service has an API configured to invoke a gateway service in the backend. This gateway further verifies the token before allowing access to the resources. It is the authorization enforcer. The gateway is based on Spring Netflix OSS implementation using Eureka for its service discovery. And we have Hystrix, which is used as a circuit breaker to prevent, cascading errors if one error occurs in one place. And we have Zool for routing and filtering. So some of the key benefits of these UI microservices are they are all individually managed services and easily deployable independently. So this is important to note. These individual services can be upgraded without affecting others with minimum downtime. All the UI communications are stateless. This is another important point to note, thus eliminating the need and overhead of maintaining sessions. So each microservice lends itself to be Dockerized as composable units, much like Lego pieces. We are also looking at some enhancements which we hope to do in the next few releases. One is load balancing over UI and backend microservices, individual microservices that can be made over different tech stacks. So, some things implemented in React or Angular, and then we have SAP Fiori, and then we have other, SAP technologies. SAP has a zoo of technologies actually. And then we, of course, auto scaling and failover, that can be achieved at the UI layer. So in this slide, I'm going to talk about the backend microservices. And so there are two layers of microservices, so to speak. So we have the gateway, and then we have the business logic microservices. So the backend ones like sales, pricing, routing, and sourcing are the main ones. The UI request for backend resources along with the Keycloak is always received from the authorization service. This token is then verified by the Keycloak Spring instance and further passed on to the specific backend data services. So the services on top are like the gateway, which exposes it to the UI, but the one below are really the data services. These services then communicate with the client's ASE databases from Sybase and et cetera, et cetera. So some of the key benefits of the backend microservices are Spring Cloud provides us a seamless gateway for service discovery, registry, routing, filtering, et cetera. Some of the microservices represent a composable view of the data platform, especially sales, pricing, sourcing, and routing. So that's what I was saying. It exposes the whole data platform, which is a collection of big databases as composable microservices. Kafka is used for the inter-service communications, especially with the data layer. Okay, and each service lends itself to be Dockerized and hence individually deployable and manageable. This is very important to note. All services can be bundled into more coarse-grained Docker instances for deployment. And the future enhancements are pretty much the same that we have in line with the UI services. So finally, here is a view of the fine-grained microservices we have implemented. And therefore, this is the lowest level at which we can Dockerize them. In our present case, the number of simultaneous users are only in the hundreds. Okay, simultaneous users. This is why we have decided to go in for 2 Docker deployments, which can be, spooled up and down depending on how many we need. If the organization ever grows into many thousands or even 10,000s, like, let's say that our app now, we start bringing in more and more backend services, and we have tens and thousands of users, which is possible. We have almost 100,000 employees. The architecture that I have presented is scalable to maybe 2 or 3 orders of magnitude of growth in users. I have not tested this at that scale, but it is definitely in the realm of possibility. We just need to containerize it differently to address this scale. Instead of bundle microservices and components in containers, we will, in a coarse grain fashion, we will now have finer grain components in containers. So here is a possible scheme which I show you right now on how we can containerize the application if that scenario ever happens. All you really need to do is to change the configuration files and the way you package to make this happen. So you don't have to rewrite your application or change the code in any way. So what are my top 3 benefits, which my take on the top 3 benefits? This is what I feel. 1, the deployment time has come down from a day or more in previous projects to literally minutes for an upgrade. For a website that is 24/7, supporting sales and operations worldwide begin to tell you how this has simplified life for us. Secondly, the flexibility. Gone are the days when we had to give our IT a precise list of what machines we've expected, exactly what software needs to come with it, and endless discussions on why I need a particular version of software and not the version that they support, etc., etc. I'm sure many of you have gotten into these discussions. Now I just get a virtual machine or an Amazon machine unit or something like that, Google machine unit, and I have complete control on exactly what versions of software, what versions of libraries, what versions of everything goes into that particular container. Okay. And then the third big advantage is the whole management of the deployment is easier for the IT staff to do. They don't have to have competence in any one component like Kafka or MongoDB or all those fancy stuff that I have been talking about. No worries if they don't have it. There's no worry. It's all encapsulated and running. If there are no bugs, the only thing you do is to install, upgrade, and roll back. That's it. And you start and stop these containers. That's how easy it is. So in the next video, we will just give you an idea or an inkling of what this software that I developed is.
Thank you, Paul. That was very interesting. I'm sure people are looking forward to further interaction with us. So may I please request another few minutes or few seconds of interaction with us in the forum. There's a small poll coming up for us.
Thanking all the audiences and the speakers for their participation. Have a great and lovely day and hope to hear back from you soon. Thanks, everyone.